This is the screencast for section 4.4, example 3. So we've learned about the amplitude of a sinusoid, the period of a sinusoid. Now we're going to look at the frequency of a sinusoid. The frequency is the number of cycles the wave completes in 1 unit. So the period is how long it takes, how many units it takes to complete 1 cycle. This is how much of 1 cycle is in a unit. So technically, the frequency is the reciprocal of the period. So in example 3, our task, or our mission, if you choose to accept it, is find the frequency of the function f of x equals 4 times the sine of 2x over 3 and interpret its meaning graphically. Okay, and then we need to sketch the graph. Oh, here we go. All right, so f of x, I'm going to rewrite this, f of x equals 4, no problem, sine of, and that's going to be 2x over 3, so 2/3 x. That is a horizontal, horizontal stretch by 3/2. Remember, horizontals, you take the reciprocal because it's doing the opposite thing to the input. And we're going to, since 2/3 is less than 1, 3/2 is greater than 1, that's actually a horizontal stretch. So the natural period of sine is 2 pi. So this is going to be 3/2 times 2 pi, which is going to be 3 pi. Well, since the period is 3 pi, the frequency is 1 over 3 pi. Like I said before, this means they are reciprocals. If the period is 3 pi, that means there are 3 pi units needed to complete 1 cycle. So in other words, this is 3 pi units per cycle. The frequency then means that there will be 1 cycle every 3 pi units, which then says it's 1 over 3 pi cycles per unit. So basically, between numbers 0 and 1 on the x-axis, 1/3 of this graph completes. Only one little 3/5. Alright, now let's take a look at sketching a graph of this sinusoid. Now my strategy for graphing sinusoids is I start out with, since the period is 2 pi, I just go with the quadrantal angles to start with as key points to translate in the graph. So for example, I will start with the sine of 0 is 0, the sine of pi over 2 is 1, the sine of pi is 0, the sine of 3 pi over 2 is -1, and the sine of 2 pi is 0. So now I've, on the coordinate plane, gone all the way around in standard form to see what each quadrantal's measurement is. I could plot those, and that would be the plot of the normal sine curve, but now I'm going to take the transformations and change these points. So my first transformation is a horizontal stretch by 3/2, and the second one is a vertical stretch by 4. So a horizontal stretch by 3/2 is going to take the x-coordinate and multiply each of those by 3/2. So this one's going to be 0, 0 still. This one, multiplying by 3/2 is 3 pi over 4. This one is going to be 3 pi over 2, comma 0 still. 3 pi over 2 times 3 over 2 is 9 pi over 4. This is getting weird. And then 2 pi times 3/2, oh, that's better. The 2's cancel, so that's just 3 pi, comma 0. Now I got to vertically stretch each of those by 4. That one's the easy one. I just multiply the y coordinates by 4. So now I have all of the new points on my translated graph. Alright, well, this actually gave me a hint. It says graph this between -3 pi and 3 pi, and then -4 to 4. So my y-axis is going to be pretty easy. I'm just going to go -4, -3, -2, -1, etc. Then on my x-axis, that's kind of where the catch is. There are denominators as high as 4. So if I go by pi over 4, to get all the way out to 3 pi, I'm going to need 12 marks. So I'm still going to go by pi over 2's, I'm going to make every 2 marks another pi. So then each of these marks, this one would be pi over 2, 3 pi over 2, 5 pi over 2, etc. But in between those marks will be my pi over 4s. So if I want to plot the point 0, 0, yes, I know, Miss Larson, that was the easy one. All right, now, how about 3 pi over 4, comma 4? Well, pi is right here. Pi over 2 is right here. This is 3/4 pi, so that's going to be right in the middle, comma 4. Now the rest of it should fall in place as a pattern, so let's make sure our points line up. 3 pi over 2, comma 0. So 3 pi over 2, 3/2 is right between 1 pi and 2 pi, so that's right here, comma 0. The next one's going to be 9 pi over 4, so that's 2 pi and another pi over 4, negative 4, so that's down here. And then 3 pi, comma 0. Now the directions say sketch this throughout the whole window. Well, I've already got 1 period of this translated sine curve drawn, making sure that my mins and maxes are nice and curvy. No Charlie Brown t-shirt zigzag things, make them nice and curly. And then I'm going to follow my pattern backwards. I have basically, let's see, this is a maximum, so my next one's going to be a minimum, a 1.5 marks over at negative 4. Then I'm going to go back in between pi and 2 pi, right on. So basically every 1.5 marks, I'm creating a new point. So this one's going to be up at 4, and this one, 1/2 and a whole mark is going to be back at 0. So now, what's nice about these sinusoids is they have a lot of symmetry in them, so you can really tell when you haven't graphed something correctly, or maybe your arithmetic didn't work out or something like that. But your graph should be nice and smooth. It should be very, very symmetric, and I would also like you to please label 1 period's worth of points. So in this case, I'm going to label the points I've got. I've got 0, 0. I've got, let's see, this is going to be 3 pi over 4, comma 4. This is 3 pi over 2, comma 0. This one's 9 pi over 4, comma negative 4. And this one is 3 pi, comma 0. So now I have answered the question. I have found the frequency. I have interpreted it. It means there is 1/3 of a cycle per unit. So between 0 and 1 on the x-axis, so this little tiny bit here, only 1/3 of the curve has happened. The rest of it still needs to go to happen between all the way out to 3 pi. Then I've also sketched a curve on a specific window, negative 3 pi to 3 pi by negative 4 to 4. The now try problem number 17 says graph 1 period of the function. Use your understanding of transformations, not your graphing calculator. Be sure to show the scale on both axes. And by showing the scale, I mean at least, label every pi or so I can see how you've scaled your x and y axis. All right, so we're going to graph 1 period of this function. Let's see here. Well, I'm going to start out with my quadrantal angles. So the sine curve, quadrantals. The sine of 0 radians is 0. The sine of, let's see, pi over 2 radians is 1. The sine of pi radians is 0. The sine of 3 pi over 2 radians is negative 1. And the sine of 2 pi radians is 0. Now, the only transformation I have here is a vertical stretch by 2. So all I need to do is go through and multiply those y coordinates by 2. Now my instructions are extremely specific in that they say graph 1 period of the function, which means if you graph more than 1 period, you are telling me you do not know what a period is. So I can only graph 1 period of the function. Now, since this sine function, its original period is 2 pi, the points that I have chose to translate cover 0 to 2 pi. They cover 1 period. So if I stick to just these points, I will graph 1 period. So here I go. Ooh, I got to label my axes. So I'm going to go, let's see, this is going to be 0, obviously. I'm going to stick to pi and then 2 pi. Maybe, nah, you know what? 1, 2, 3, 4. Let's go pi, 1, 2, 3, 4, and then 2 pi. So technically my scale is pi over 4s. And then my y's, I'm just going to go by -1, -2 units. And 1 and 2 units there. So sticking to the 1 period, 0, 0, pi over 2, so halfway between 0 and pi, comma 2, pi, 0, 3 pi over 2, comma -2, and then 2 pi, 0. So again, make sure these are nice and curvy. If you get caught in drawing these nice and curvy, start with the maximum or minimum and go out from there. It helps curve it out a little bit better. Now that is exactly 1 period of the sine curve.